Hey, Kendall. Hey, Justin. Great news.
Hey, how you doing?
Good. How about you?
Hello, this is Kendall.
Hey, Kendall. I saw you kind of like changing like different rock in there. So people were trying to rock in from different machine.
Um, no, I clicked on the join and it wasn't coming up and wasn't coming up. So I said join from the web browser. And after I got in on the web browser, the other one decided to show up. So I'm like, killed it. I'm like, I don't need to join twice and echo.
Yeah. I think I have that experience as well. I think I just opened slowly. So it took a while, and then you thought you might not be opening and joining, but it's joining later.
Hey guys.
Hey, Tony. Hey, Corin.
Hi James, hi everyone.
Hi, hey, Rudy. Maybe we just give
So
a
again,
few.
just as a reminder to folks on the phone, if you could put your company name in the title, you have to kind of do that on the fly. So,
So maybe we'll give a few more minutes and see everyone joining. Well, just kind of like an agenda here. So
so Jurang, what company are you with?
Yes, I'm just about to update the
Okay.
name.
Okay, thanks.
Yep. I'm part of Deca Technologies.
So we got Beaver Trail Fabrications represented. Good to see, Kendall. Is that a Siemens-owned subsidiary?
No, that's, you said put your company name in. That's my company.
Okay.
yeah, I think we have most people here. Yeah, thanks, Graham, for the intro. And we have a Max here, Max Clark.
Yep. Yes.
Yeah. Max, maybe you were you joining before?
Yeah, I'm from Siemens.
Oh yeah, right. Got it. Okay.
Yep.
Appreciate that. I think thanks for the quick. Okay.
Yeah, so if you hit the attendee list, there's some dots on the right. You can just put in the company name. I haven't figured out how to make it persistent, but
yeah, I think I'm gonna rename on it. Okay, I think we have many people. I'm just going to quick start. I think from last week, like we created this document. I think a spreadsheet. I think I just kind of put together what we had talked in the past few weeks together. So I think we have this went over this one. We got quite a feedback here. So we share this with everyone. And yeah, for this week, I think we were talking about we're going to get some more. I think if we can get some more roof from offset, and we also check you see we can.
I'm sorry. What about the OSET?
Oh
James?
yeah, some other vendors offset or other vendors. I mean, you can get other rules. So far, we have an Intel, right? So I think that might be good enough. So I think that's something you're going to talk about in a bit, right, Tony? Share with everyone here on your update.
Yeah. Yeah. ASC is not on here yet, are they?
Yeah.
Okay.
Are
I
you,
think it's
are you,
Roger normally attends. Yeah.
right, yeah, he was here last week, right, or last meeting. I don't know why he wasn't here. I can try to email and ping him and see he will be joining. And yeah, besides, I think we just talk about, right, if we should include cover other things with thermal and mechanical here, right? We use a YAML format since like those are in the different format. So Tony, you have any input on this one, or
I'm having a hard time reading your.
is that
Can
too
you zoom in a little bit?
Yes.
Okay, that's a little better.
So we have a thermal and mechanical information in right now in part of the CDXML, also the another like material cover bit, and then chapter D also have some section about it, and especially mechanical they have that in CDXML, right? But since we're going to use YAML, there's some information here will be mechanical related, right? So shall we kind of like redundant that or not? But I think maybe we'll decide that later since we haven't decided.
Yeah. I mean, the format is part of the discussion. I think it's really, what we're doing and getting consensus. So
Makes sense.
so Victor, you just joined. Can you put in your company name? If you go into the participant list, just look at the 3 dots and put in the company name, just so we know who's here. So Garang, you're from DECA. Good. Yeah, I talked to Craig and he said you would be joining us.
Yeah.
Okay.
Yep.
From Chiplet. Yeah. Thanks. I think, yeah, Tony, you want to go ahead and.
Yeah, I just like to do a quick update. I've had some discussions with Satish, who's kind of driving the initiative from Intel's perspective, and we talked about a lot of different things. And to just kind of a high level summary of what's we're currently proposing is we've got a definition of the die file, and there is some overlap, right? The JEP30 standard has an XML format, part of the JEP30 that describes relevant information for chiplets. The dies, it includes electrical informations, it includes physical tolerances, and Intel team has proposed a format that currently is proposed to be implemented in YAML. And I did have some discussions, and I one of the things we're trying to avoid is having multiple standards representing the same thing. And I think the concerns that Intel has, and I'm sure other fabs and OSATs and would also share similar concerns, is does it represent all the needs? So there are some specific needs that are not addressed. There's some concerns about capacity in the current JET30 format, but conceptually, if we agree as a team that we can and will modify the format to meet Intel's needs, as well as any other contributing parties, then at least they're open. So I just want to throw that out there. So TSMC also has a YAML format as part of 3D Blocks that describes information, and there's many limitations in that. And I know I've shared it with some other folks, Cadence and Siemens, and there are some issues and limitations of that, and kind of the way they interpret some of the information is, I would say, more TSMC centric or biased and maybe not addressing the entire scope of the problem, which extends beyond just, silicon and silicon interposers and even organic interposers. So that's a concern. So I think if we can consolidate on a format that we're comfortable, and at a minimum can be translated to 3D blocks, that's probably a reasonable starting point. And ideally, we may even be able to get Intel. Certainly, I'm sure Intel will support this. I mean, TSMC and likely Samsung. I think if we can get 3 or 4 foundries to agree on a format, I think that would be good. I think there's general agreement in the industry. We need to standardize on a format. And as soon as we kind of have those discussions, everybody says, "Here, I got a format. Let's use my format." So that's why I think driving this through OCP gives us kind of a level playing field where we're open to everyone to contribute and work together collectively as a team. We'll take inputs from anyone, and I think we want to address the needs of the entire ecosystem, not necessarily just the largest player in the field. Certainly, they're an important player, and we need to make sure that they're supported. But so that's what we're trying to do, kind of big picture thing. So that's the chip format. The other thing is kind of defining the stack up. Have the different chiplets get placed and flipped and rotated, and kind of your positional XYZ type orientation. That is addressed in 3D blocks, and it's my understanding. And Justin, correct me if I'm wrong. I think Intel is basically embracing 3D blocks for the 3D stack. So is that a fair statement?
We're looking into all formats. I don't think we are planning to support it, but I don't know about the full. Like it's all the same stuff. So overall, like we are planning to support it. But still waiting for some clarifications and feedback from TSMC on that side. But as of I think as far as I know, like as of today, we are planning to support it. And
well, yeah. So supporting means we're adopting it as our standard, or we'll be able to support it from our standard. There's a subtle difference, but an important difference. I spoke to Satish, and he said that we were planning to use the 3D blocks format for 3D stack. So
okay, then okay, then that should be the then that should be correct. If Satish said that, then yeah, that's the correct statement.
And Justin, I think you're the actually hands-on guy driving the stuff. Do you agree with that? Justin, you're on mute. No, I'm sorry, not Justin. Is Chris on the call?
No, I don't see Chris.
Okay, so I think Chris is actually driving a lot of this stuff. All right, maybe Zane, you could just take an action to check with Chris and Satish to confirm what I said.
Okay, this is Intel Chris, right? Chris Ankenbauer?
Correct.
Okay.
Yeah. Okay. And then,
I don't see Chris on the email list though. Can shall we send in the invite?
Well, David, I asked earlier today, didn't we add him to the list? Maybe not.
Yeah.
I'm sorry, who?
Can you put Zane, can you put Chris's email in the chat?
Yeah.
Okay, so So the other kind of component, which is in 3D blocks as well as Intel's format, is kind of wafer sorting, support for wafer sort. And there are definitely some deficiencies, if you will, in the 3D blocks format. I know Intel does things a special. I'm sorry. Okay.
Maybe somebody spoken by
Yeah.
accident.
So I think right now we're not comfortable with the 3D blocks wafer sort support. So Intel is supporting that in their proposed standards. And then the last part of it are the assembly design rules. And in my view, it kind of covers two classes of rules. So one of them are the actual routing rules, and this would be kind of what has traditionally been represented in a design rule manual, typically provided in PDF format. So I think we want to be able to describe those rules in a machine readable format. So and this includes a whole host of rules. And then there's kind of another set of rules which are really more higher level package placement rules, if you will. So this is, how you're going to place these things. There may be, rules related to stiffeners and package cavities and how you embed things in a substrate. A lot of, very packaging technology specific type of rules for actually creating a package, a full production package, deliverable, and TSMC really doesn't play in that space, and fabless semiconductors don't really get involved in that. But people who are actually building a final product that is going to be in a package, those are a class of rules that we want to accommodate in this standard. So I'm calling it PADK, so it's kind of a superset of those types of rules. Oh, okay, so that's kind of the high level strategy. So there's a lot of moving parts here, but I think collectively, if we agree to work together, I think we really can drive the standards here. We've got the support of JEDEC behind us. Michael Durkin is kind of one of our representatives, and he has discussed some of these new areas that we're working on, and they are agreeable to kind of sponsor these formats that we're developing as a JEDEC standard.
Right. So hang on, Tony. So
yeah, and I'll let you say exactly where we're at. This may not be official release, so we need to be careful about what we talk about, but why don't you just
right. So we have agreed in principle to at the committee level needs to go through the BOD level, and that meeting is on the 7th of November to standardize the all the design kits because of its close relationship it has to the part model and the terminologies consumed within the part model. What's not agreed yet is if we will substitute from XML to YAML or to JSON. So that level of discussion has not happened yet, and we need to wait until after the 7th of November to get the green light from the BOD that the committee can increase the scope to cover this. First of all, so
okay,
don't have all those answers yet.
Right.
Yeah.
That's probably a good thing, because I don't think we've collectively agreed on the format yet either. And format is important, and that is a whole discussion in itself. I mean, there's pros and cons of each of the formats. Ideally, we could adopt one format, but there's there is some momentum already. You know, JEP 30 is a published industry standard. It is in XML. TSMC has got a lot of momentum around their format. That's YAML, and then we're also bringing up JSON. So I think, you know, we've got a lot of experts in this group that can discuss the pros and cons and compatibility between the different formats. But you know, I think it's more important first to agree on what we're going to do and the scope of what we're doing, and then, you know, we can hash out the different formats and the pros and cons.
Oh.
Okay. I just want to bring up a so next week I'm going to be presenting a 3DK presentation at the OCP Summit in San Jose, and I'll just share one slide that I plan on showing. How do I share here? Share.
Yeah, there should be a share button at the bottom. Yep.
Yeah. Can you guys see this?
Yeah,
Yeah.
I can see.
Yeah. So this is a new press release that actually came out a couple days ago. I'll let you read it, but you know, this is you know, showing that, you know, unified structure that supports both chiplets as well as electronics. The focus in this group is on the chiplets, but the idea is it describes the information for the chiplets necessary to support system and package. And this really does the part model. One of the added benefits of this is it does support a chiplet marketplace, which is really part of our charter of CDX as well as ODSA. So chiplet providers can provide the information for chiplets in this format, and that can be used by system integrators to browse a chiplet catalog, if you will. I mean, we're really setting up the infrastructure to do that. There's really not many chiplets out there today. But you know, it is happening. We're trying to create this ecosystem to enable that. So they can actually browse a catalog, kind of a DigiKey type of catalog, and actually potentially even be used for a delivery and procurement platform as well for chiplets. So this really does form the foundation of you know, a chiplet marketplace. So I mean, it is a format. It's an industry standard, so we can leverage that. There are some, you know, gaps right now in the current implementation. From the few conversations that I've had, I don't think they're unsurmountable. We do have a good set of test cases from Intel and requirements documents, so I think that's also an excellent starting point. But I'd like to invite other foundries and OSATs to provide, you know, to review the formats and the requirements, and to provide test cases to make sure that we're covering all the needs. And I think if we do that, you know, I think there is certainly some benefits of, you know, leveraging this format, since it is an existing standard. There's quite a bit of effort to get this thing as a standard, but you know, we've got precedence here with the JEP 30, and you know, the goal would be to extend that on these other things that we're working on, the you know, the MDKs and the PADKs. Another thing I did want to bring up is SI2. It is another, what would you call that, Michael? It's not really a standards body, but a similar industry consortium as OCP to some extent, competing. And they were working on a format, a proprietary format that was being provided by Synopsys MDK, and they were not taking an open approach to that. So we've declined, and others have declined to support that format. I believe that SI2 is no longer supporting that format. I was asked to present kind of what OCP is doing in this area for 3DKs. I presented a version of this presentation that I will be sharing next week. I've actually shared, presented an earlier version of this at DAC. So there seems to be a lot of interest out there in the industry to have a consolidated set of design kits, and they have agreed it does not make sense to work on competing formats, and they certainly we would welcome anybody into OCP to work with us on this. It is an open format, so they're welcome to view that. And they would they have a kind of an approval process in the committee, so they said they would certainly be willing to kind of sanction our format, but it would be more, they'd have actually a set of technical teams looking at that to make sure that they were comfortable saying that, yes, we are supportive of this standard. So I think that is something that I see no reason why not to get them to buy into this. That'll just give us more momentum to kind of really drive this throughout the industry. And there's probably a dozen different efforts going around all over the world on this, but I think if we work together and we move quickly, I think we can really take some industry ownership of this.
That's good.
Okay, so that's
Yeah,
kind of
Tony, the best description of SI2 is they're actually R&D joint venture between its members.
Okay, and another thing with their standards, they're not quite as open as OCP. You need to be a paying member to have access to the format, so a little bit different.
Are you saying
That's
that from a JEDIC perspective?
No, I'm talking
SI2.
SI2.
Yeah. Okay.
Yep. Yeah. And I think historically, at least from my perspective, JEDIC seems to be a larger standard in the packaging world, right? So IEEE is driving a lot of the stuff in the IC world, but the worlds have collided, so it could go either way. But I think there's a lot of momentum right now with JEDIC, so I'd like to continue leveraging with what we have.
Makes sense.
So David, maybe you could just give us a 10-minute, and David and James, kind of a 10-minute kind of overview of the different formats and the pros and cons, and I think we can probably have all three of the proposed, JSON, CDMXL, and YAML. There is some operability between the different standards, but there's a lot of advantages and disadvantages of the different formats. So, and Michael, feel free to contribute as well. So
Yeah.
hand it off to you guys to kind of, let's have a short format discussion.
Yeah.
Yeah, let me.
Before that, Tony.
So before you do that,
first?
there, Justin has pulled together a presentation of the comparison of the three different formats: XML, YAML, and JSON. He's also gone into the that DAI format from a file from Intel, and he has represented. He's created already an XML schema that represents the data that's inside that file. So he can go through that as well. So, David, do you want to go through first and then let us do the second piece?
Well, it's about time, Mike. I mean, I asked you to do that 3 hours ago, and you. Wow, I'm impressed.
Before that, Tony, actually, there's Intel spec proposal. Do you want to share that first, or you want to do that later on, or is that something able to share with Tim? Yeah.
So I did ask Satish, and he said we can share what I sent you. But let's have the discussion first before we share that. And you know, we can post that in our GitHub. We probably should just double check and make sure that's okay. But Satish said we could share that with the CDX group. Some of the other the rules, I think they're not quite ready to share that information. They're still trying to get a little more feedback from the EDA vendors. So there was a meeting last week. Whoever's talking, if they could put their phone on mute. Okay. So yeah, so we need to check. So last week there was a meeting that Intel hosted, representatives of each of the EDA vendors, Siemens, Cadence, and Synopsys, and they kind of shared their specs and proposals and requirements. It was a good presentation, and they have asked feedback from each of the EDA vendors. So we're all reviewing that and providing that feedback to Intel. So I think based on that feedback, you know, we may see some changes in some of that stuff. But he said the die format, I think, was good enough to share in its current form.
Okay. Yeah. So should we discuss that format first, and then we will talk further about this?
No, let's let Michael or Justin share what he's done.
Right.
I think let's do that for now.
Okay.
Okay,
Yeah,
Justin.
let me get it pulled up real quick. All right, hopefully you guys can see my screen.
Yep.
Yes.
All right, so let's see. All right, so I started off just a quick summary of some of the key points of to analyze between the three different formats. First one being machine readability. XML tends to be slightly more machine readable than some of the some things like JSON and YAML, just due to the closing tags. Like if you're writing your own parser, then you may accidentally jump out of a scope, if you will, in like some of these other formats if you're not careful. So having the closing tags that has the name of that element that you're in is really helpful with machine readability. Whereas with JSON, you're using the curly brackets and square brackets for opening, closing different scopes or hierarchical depths. And then with the YAML, you're using indentation. Human readability, XML and JSON, for the most part, would be about the same. The only main difference is that the closing tags, again, with XML, add visual clutter, and with JSON, the symbolic tags can cause confusion as which scope you're in. And then with YAML, you may end up interpreting the indentation incorrectly, but out of the three of those, YAML would be the best of the three. For tooling and software, I would say XML and JSON are roughly the same. Tooling and software being like professional editors or viewers, visual design, like with the Altova's XML Spy, there's like a graphical representation of a schema that you can use, or with like a grid view for an actual XML or JSON file. And those really help with creating and editing the different files. And whereas with YAML, you're mostly working with pure text editors or some things like Visual Studio Code that do have like the syntax highlighting, but again, it is mostly just text editors, and you don't really have very many or any at all graphical editors. Then schema wise, with XML, you've got the XSD, the W3C schema, XML schema recommendation. That's well known, used all over the place. JSON, it has a schema. It's the JSON schema. It's when it's used, or when a schema is needed for JSON, that's the one that's typically used. And then
Can you provide just a very layman's definition of a schema?
Yeah, schema is basically like a definition of what's allowed and not allowed, the ordering or any kind of requirements of a actual instance document.
It helps you visualize the data architecture in a very simplistic way. So if you are trying to create a structure for a file, doing it through a schema is like magnitudes of more efficient than doing it through a text editor. I give you an example. IPC tried to do product change notes and product discontinuance. They've been working on it for more than 15 months. When we switched over to the XML schema using Altova, we completed it in 6 hours. So it's that much less opportunities for making mistakes, and much greater capability for detecting errors in your structure using a schema, using an XML schema.
Okay, thank you.
One thing about the schema here is very similar to a database schema. So I think you can fix a field, say like it only contain the number. So the moment you start putting a text, it will not going to be confound anymore. It's going to give you an error. So I think that helped too. I think I give a lot structure as mentioned. I think I help. I think it's good for. I think you want a more structured data. I think more stricter rule. I think so more people following the standard there. I think it's a better way, actually a standard way to enforce this thing.
Mm-hmm. Right.
Go ahead.
So JSON has a schema. It's not very commonly used, but there's basically just one, and it's the schema, I guess, for JSON. There isn't really any others. The YAML, typically for YAML, you're not going to be using schemas in most instances. There is a schema, which is an extension to the JSON schema that allows for everything that JSON allows for, while also adding in certain features that are specific to YAML. The parsing speed, XML, it's going to be a little bit slower, mainly because of the closing tags. The closing tags end up making the files a little bit larger. That kind of hits on with the next category. The JSON parsing speed, it's going to be the quickest, just because it's been around, being used very abundantly in many different use cases. So parsing speed has been optimized to the max with it, and then since it only uses the symbolic opening and closing of like the associative arrays or lists, there isn't a whole lot of confusion that can happen with the parser. YAML parsing speed's right about the same as JSON. It does have some more advanced features, so it can take a little bit longer to parse, but we're talking like fractions of a second anyways. File size, kind of touched on it with the parsing speed. And then data integrity, with XML, it has the keys and key refs, assertions, X query, bunch of different additional tools and things. I can't think of the right word, sorry. They basically assist with the integrity of the data. So like keys and key refs are basically like if you have a structure, it has an ID, and you want to reference that structure by its ID in a different place, then that ID is the key, and that reference to the key is the key ref. Assertions, it makes use of XPath language, that's where you state this path condition, the result that you want based on that condition. And that can be very powerful, such as being able to determine if a certain element is actually populated or not populated. And it makes programmatically going through the data a lot more efficient. JSON doesn't really have very many advanced features like that that can help with data integrity. There may be some that I haven't seen or noticed looking into the spec, but that's where YAML had kind of took it a little bit further with their extension to the schema and to the language, if you will, and where they added relational anchors, which are basically IDs and references to those IDs, like how the keys and key refs work in XML. However, with the parsers, typically they will copy the entirety of that structure that the ID belongs to and populate it within where the reference to that ID is at. Hopefully that made sense. Yeah, I go into a little bit of depth with some of these additional slides, but for the most part, it's what I already spoke on. But I do have some examples of like a set of data represented in the 3 different formats. So this one being XML, you can see there's a ID here that's being referenced in the ship to. So if the bill to address is the ID is this, then you know the ship to using this ID can ship to the same place. Pretty standard XML file for the most part. Little information about JSON, which I already spoke about. This is the same information in JSON. You can kind of see it's a little bit more condensed and a little bit less visual clutter due to the square brackets and curly brackets instead of the opening and closing tags with the element name as seen in XML. And then
now I want to make it, sorry, can you go back there?
Yeah,
Like make a comment
sorry,
on that one?
There we go.
So where you see this curly bracket, for example, under items, you have opening and a closing curly bracket, but let's assume that you had a deep 3 and you had another curly bracket open after the first curly bracket. And then you have the same thing going on 4 and 5, 6, 7 levels deep. Now it becomes very difficult to figure out when you're closing scopes. So in the beginning, when Justin mentioned that when you're in JSON and you don't have a proper closing tag, it's you have to count all of these curly braces down in a branch to know exactly what level of depth you are in that tree. It's not visually obvious to you. So this structure is nice to read when it is flat. When it becomes very hierarchical, it becomes very easy to make mistakes, very easy to start jumping from one scope to another scope, that you wouldn't have that problem in XML. Okay. Okay, Justin, you can go on to the next one.
Yeah, so then we have in same example, except in YAML. You can see it's a lot more condensed. The information is laid out exactly how you would think. You have like got this bar on the top. I can't really see the very top of my screen, but I think it's receipt at the top, and then date, and then you got a customer, and then you have the indentation. This one uses 2 spaces. You could, in theory, use 3, 4, however many spaces you want to represent an indentation to define a child of an element.
Yeah, it
And
does
then
have
this-
more.
Now, again, this has the same problem as JSON. If you go to a very, very lengthy depth tree, and your text starts to wrap onto the next line, now it becomes very difficult to know how many indentations you have and where exactly that data with respect to the branch. It's not crystal clear anymore. It gets messy. If the structure is flat, it's definitely ideal. If the structure is going to get hierarchical, then it is not as much ideal as XML. So if you think of files that are millions of lines long because you have a million bumps in it, and you want to represent that in a more condensed structure like what we have in a part model, then you're going to have a hierarchical structure. You're not going to get away from that. But that gives you, while it gives you more complexity, it gives you much better way to condense the data in as small an area as possible.
Right. Yeah, so then that kind of brings me to I guess one last point. It really touches on what Michael's been hitting on with JSON and YAML being they're perfect whenever it's a relatively flat structure. And I guess that's mainly it's mainly with their intended use cases, if you will. For YAML, primarily its intended use case is for configuration, for configuring a certain software, configuring a website, whatever it may be. Its main purpose from the get-go, I believe, was for basically a fancy configuration file. And then with JSON, there is the additional use case of server to server, server to client data transport. So typically, whenever you get JSON from like a website, like if you're sending an API request and getting a response back, typically you're not even going to be, as a human, seeing that data. You're typically going to be bringing it directly into a tailor-made parser where you need to know the structure, but effectively human readability doesn't really come into play. It's more I guess with YAML being human writability, where it's really strong, because the readability, it's typically going to be done by a machine anyways. But yeah, and then intended use case for XML being data interchange, server to server, client to client, server to client.
Bring up the example that you showed me earlier about the XML representation of the DAI file that you got from Intel.
Yeah, you know,
So
the schema.
Yeah.
Okay.
So while he's doing that, so Justin took the specification from Intel, and he actually took the die file in YAML format. And what he did was he recreated what that structure is in exactly the same representation, I believe, as in the YAML file. Now, what he discovered was that even though the specification was there, the compliance of the file did not comply with the specification. There were pieces of that file that are out of compliance with the specification, in which new structures were added that's not described inside in the specification. That's one of the problems you have with YAML, because the absence of a schema means that if you're going to have multiple organizations following a paper document like a specification, what they actually create may or may not comply with that specification, because you don't have a schema to do the validation against. For a new standard that's going out into the industry, I think that's a dangerous situation to get in, because you're ultimately going to have an interposer in which you're getting dies from many different companies. How do you enforce compliance to the specification? All right, go ahead,
So
Justin.
Michael, is this compatible with the JEP 30?
No, we haven't done. We didn't get that piece done yet. So
okay.
What we can, what all we did now, well, let me ask Justin the question. Did you actually get that piece done? I don't think you hadn't shown me that earlier. We need a bit more time.
Yeah, we need more time with that.
Okay.
The one thing to note is this is mostly the same as what the specification has, with some added, a few added things from some of the example files that I saw that were in the example files that weren't in the specification. And then there is a slight addition in the property headers with how that's kind of handled. I didn't do an exact one-for-one. I tried to do a slight improvement on it, but yeah, I mean,
right. But conceptually, we can adapt our current format to cover these test cases.
Right.
Yeah.
All right. All right.
Now,
So I think
another big thing that we discovered here is there's too much focus being put on the format of the file. There's not enough focus being put on the data architecture. The structure, how you organize the data, it can be visualized, and we can share that with you. If you go down through some branches here and show the one that had for example, the 3 different types of shapes, the polygons, the rectangulars, and how you did that one. And by creating the proper structure on how to do this, has much more impact on data integrity, minimizing the size file, eliminating duplicity. That's what the core of a standards body should be doing, is making sure that we get that structure right. The format of whether it's XML or YAML or JSON should be the last thing on our minds.
well, yeah, Mike, I agree with that statement. I think the human readable and which format are secondary. The structure, I see the value in that, but performance is very important, and that did show up kind of weaker in terms of file size and parsing speed. And it's got to be, I mean, it's got to be competitive. I mean, because these pins are going to grow. They're not going to get smaller. So we're talking about 10, 100 million. We're going to be talking about billions, and at some point,
Right.
and we need to make sure that it's not going to blow up. So that is very important. So I think we need the large test cases and to run them and determine whether or not it's acceptable.
Yeah, but
Tony,
Tony, oh, sorry, Michael. I just want to interject just a little bit of experience here and there. this is a data exchange methodology. Don't get the perception that the tools that use this accepts this as the format is the way they're going to store it within their application. They're going to take this, they're going to parse it into their application so that it's optimized, and then they're probably going to leave this behind. That this is an important factor. It's just like if you look at the standard printed circuit board today, let's just use the old Gerber format. There is not a CAM system in the world that works based upon the Gerber format. They all take this content in, they reprioritize it, they restructure it to best fit their tool and application. So the reading and writing of this is a one-off thing. A person receives this, they read it in, it goes into their solution, and then that's it. The file is pushed aside. Just keep that in mind, because I have this comment with the 2581 group on the IPC side. You know, these files are huge, right? 300 a gigabyte, they're huge. But when I read that into our solution to start working it, I read it in and then I put it to the curb, because now it's in my product and nobody cares once it's in the product how it got there. So just keep that in mind, because I agree with Michael that if you don't have this structure, you're going to be arguing with people whether a file is correct or not all the time. Today, when I generate the 2581 file, I load it into XML SPI like you said, you see here. There's a button on the top there that says validate. You push it and it automatically validates against the schema and tells me whether or not the structure of the content is correct. It can't tell me if the file, the actual content is correct, but it tells me if I comply with the schema structure.
And what Max is saying is very important, because that schema can be on a standards body's website, like what you see with the part model. And then any company worldwide can create a part model file and validate it against that schema. So that drives global consistency to the structure. And I think that's incredibly important, because we have seen in Siemens and in JEDEC and in IEC, where they have a definition of a file, but both standards, two different standards bodies, started using terminologies in different ways. And so this specific terminology means, in one case, terminal the terminal thickness prior to plating. In another place, it means the height of the standoff on underneath the device. If that's the type of problems you need to avoid. With a young standard going out trying to go across the industry, I think you need to define the standard through a schema structure like this, and later on, if you really want to convert it into a different machine format, do the translation afterwards.
Okay. All right. We've got 2 minutes, so we need to wrap up here. I do have a hard stop. So this was excellent. I thank you for this, Justin and Michael, for putting this together on short notice. You know, food.
Can we?
Anyone else want to provide some quick? Go ahead, David.
Yeah,
some quick comments.
Yeah, just a quick comment. Maybe we should continue this discussion next time again. I disagree with some of the conclusions that were presented, and I think there's probably I wanted to provide a little bit more insight on some of the other formats, because I get to use all three daily. And I kind of have a view, but I generally agree with the overall statement that really talking about the file format is a waste of time. All of these formats can be loaded in a few seconds. No, doesn't matter how big they are.
And they are interchangeable, right? We can migrate the data from one to another format.
We can migrate from one to the other. We can create schemas for all of them. Schemas are standard for all of them. So they all, in my view, they're all on par. Generally, JSON and YAML take a much bigger use because they're a little bit easier to read, And if you have to create a file, these two are easier to create than XML, right, by hand, if you have to create it. But once we get into tool generation and tool reading, probably talking about the actual format is kind of waste of time. If you think about experience of existing formats that come to any close to these three, Liberty is one of the standard formats that's being used. That comes closer to JSON. And that one is already taking, like a Liberty file for a standard cell library will have tens of thousands of standard cells with tens of thousands, right? Each cell is going to have a few pins. We're talking then about hundreds of thousands of pins with gazillions of timing entries and things like CSS and so on. Reading these files these days takes a few seconds for each, right? It's not the reading that's the difficult part. It's data interpretation that needs to be converted inside the tool. Right.
Okay, David, let's continue this discussion for the next meeting. I think.
I think.
Yeah, let's continue.
I just wanted to put a stake in the ground.
Yeah.
Yep.
A quick thing,
All right.
I think, Justin, can you share the slide so you can share with everyone? And also can you provide your email so we can send you the updates there?
Yep.
I added Victor to the he's on the invite.
Okay, sounds good there.
Okay. Thanks, everyone.
All right, thanks.
Thank you.
Thanks, everyone.
Thanks.
Thank you,
Oh,
Justin.
yeah, right.
Right.
Justin, the slide, if you can share, that would be great then.
Yeah.
All right, thank you.
No problem.
Thank you.
All right, bye.